Thanks for tuning in. My name is Alan MacDonald, and I'd like to give you an overview of the Upgrow Hidden Crisis Project, a research project funded by the UK Government with the aim of understanding more about the extent and causes of poor functionality in African hand pump boreholes. The project began in 2015 and is finishing this year. It's involved 40 researchers from across the UK, Ethiopia, Uganda, Malawi and Australia. Poor functionality has been a plague on rural water supply for decades, and there is no quick fix which will solve this overnight. So our guiding principle for our work is to acknowledge that the underlying causes are complex, but with interdisciplinary approaches, the reasons can be understood, anticipated, and ultimately mitigated. There have been 5 main objectives to our work, with 4 phases of fieldwork shown in the diagram in the top right. The first objective was to actually define what a functioning water point is. That's more difficult than you'd think. Then, to take our definitions and apply them to the 3 countries to try and identify the scale of the issue. Thirdly, we investigate the reasons why sources are failing through 18 months of gruelling interdisciplinary fieldwork. Fourthly, we set up longitudinal studies using community researchers in 12 villages in Uganda and Malawi to gather a rich data set of seasonal variability and the impact that poor functionality has on individuals, households and communities. Lastly, throughout the whole project, we have tried to make sure the research is usable and taken up and used by the most relevant people. In the time I have available today, I want to give you a taste of what some of the main findings have been from the research. Donald, John and Luke will give much more detail about certain aspects in the presentations to come. In the first 2 years of the project, we were defining and mapping functionality. We found that in many previous studies, functionality was not actually defined or was assumed to be a binary division between working or not working, with sometimes another catch-all category, partially working. After much trial and error, we found a tiered definition really useful for our surveys. First tier was, is it producing any water or not? That binary definition. Then secondly, going into more detail, was it producing the design yield of the pump? Usually about 10 litres per minute. And thirdly, was it reliable? Here we defined it as working for more than 11 months in the year. And in total, this gave us 6 categories when we added in the abandoned boreholes. Applying this method gave striking results. Using a standard binary definition of working not working, we got results of 82% functioning. That was the same as government figures. However, if we added in whether it was producing the design yield and also reliable, the functionality rate fell to below 50%. So definitions really matter. We've documented all these results in 3 reports, 1 for each country. We also explored the management arrangements of the hand pump boreholes. We used 4 categories: the financial system, the affordability and ease of maintenance, the decision-making process, and the availability and strength of external support. And we didn't limit ourselves to the water committee, but looked at all the water management arrangements in the community. So we carried out these surveys at 600 communities to find out how the arrangements were working. The survey found that overall, water management arrangements were generally good, although there was some variability within and between countries. We then took the obvious next step and compared the performance of local management arrangements with the borehole functionality. We used a number of statistical approaches and got some really interesting results. See, overall, there was no strong relationship between the capacity of the management and the functionality of the borehole. Of the 4 management dimensions, only the affordable maintenance and repair predicted, albeit really weakly, borehole functionality. These results provide some very limited support for the persistence of the policy of community management. However, this is complex and water points do need to be managed in some way, and in some situations community management might be the only option. We also examined the microbial and chemical quality of water from hand pumps. These surveys were undertaken in the dry season and water points chosen at random within the 3 countries. These showed that overall the majority, 72%, of hand pump boreholes that we surveyed provide good quality dry season drinking water, as defined by WHO. Within this overall picture, the largest constraints were from thermotolerant coliforms, shown in the left-hand graph here, and they were exceeded by 21% of the sites. Health-based chemical drinking water quality values on the right-hand side were exceeded at only 9% of the sites and were found mainly for manganese, fluoride and nitrate. The high percentage of manganese exceedance is of interest, and it challenges the decision by WHO not to formalise a health-based guideline for manganese. I found wherever I've worked, I found a significant proportion of sources with elevated manganese. However, overall, the survey showed good news that microbial water quality can be tackled with better construction, and that should reduce the problem of contamination in the future. The next stage of our work was a forensic analysis of 150 water points to find out why so many were not performing well. This involved 18 months of fieldwork, deconstructing the 150 water points and carrying out lots of tests and discussions with the community. Donald, John and Luke will go into this in much more detail in a minute, but I'll give you a taster here. From the physical tests, 5 points stand out for me. Corrosion was ubiquitous in India Mark II pumps and rising mains. Secondly, the aquifer yield was a strong control on the functionality of water points. Thirdly, the rising main was often below the standards set for the hand pumps. And 4, on a positive note, groundwater recharge was mostly sufficient to sustain the hand pump. And lastly, there was a significant minority of sites with very deep water levels. They were mainly as a result of competition from other users. For the social science research, we have 4 points here, and Luke will go into a lot more detail in a minute. Firstly, management is often through existing community groups, institutions and processes. Going with this grain may have advantages. However, there's questions arising if this will entrench existing inequalities. These need to be explored. Secondly, a consistent story across the 3 countries was the challenges of district support, be it finance, motivation, accountability or technical skills. Thirdly, we found that communities were often under high water stress. The community diaries showed regular pressures from funerals, cultural events, which are compounded during dry seasons. And lastly, the huge additional pressure put on sources when neighbouring sources fail and communities have to share. So to conclude and bring together this rapid overview of the results of the research, I have 6 things to think about. Firstly, definitions of functionality really matter, and good statistical design of the surveys. For our different countries, that meant the difference between 82% and 22%. Secondly, people manage water in very different ways. There's no one-size solution to water management. Thirdly, poor functionality and high demand have real and frequent impacts on individuals and whole communities, with the marginalised often suffering the most. Fourthly, the reasons for poor functionality are complex and variable. Poor aquifers, deep water tables, the quality of material, constructions, and all these different factors mean that regular maintenance and repair is key. And also, by applying the right methods, you can work out what the main issue for failure actually is. And this then highlights the changing and important role of government, both at the district and national levels. A final point emerging from this work is that in many situations, the aquifers are only just managing to supply a hand pump. So when there's lots of plans to have higher yielding sources for reticulation, be it for rural, urban areas or for irrigation, a lot of these aquifers might not be able to sustain these yields. So I hope you've enjoyed that rapid tour through our 5 years of a project. If you're interested in any aspect of the research, then we've got a large and growing database of resources, from academic papers, policy briefs, to the sort of methods we've developed. And in time, by 2022, all the data we've collected, that's over 2,500 days of fieldwork, will be accessible to all to examine and work on. Thanks very much for listening.